Hopefully, I think we are live. Hopefully, I think we are live. Yeah, okay. So, hey guys, hope you're doing okay. And basically, today, what I want to do is make sure that I can have function calls with arguments. And what I mean by that, basically, I want to be able to do this right here. I want to pass arguments to any sort of function that I have, and with that I can use that to do some sort of operation, and whatever we usually do with programming languages. Right now it doesn't really work because we are not checking this signature, so we are basically just parsing this, creating the AST for a function definition, and not using that for nothing, basically. And now I want to start using it. The one thing that I think I should be mentioning is that on my last stream I was implementing scopes, and I wasn't really successful with that because I was tired and I didn't really know what to do at the time. But I was able to do that later, which means that we currently have scopes inside of this programming language, which is quite nice. So everything that we have in here is inside of its own scope, which means that these values right here, they don't exist outside of this scope. I can even show you how it looks like right now. So if we want, for whatever reason, let's say that we have a value f and it's referencing something that is outside of the scope, which technically it is, right? So value is outside of the global scope. If we try to run it, we'll say that it's either not defined or out of scope, which it is in fact out of scope. But if we go back and remove the scopes, it should be working just fine. Now, there was another error just because this right here I commented it out, but that's okay. So, and how did I do that? It was a little bit of a big change. So if we go into the AST real quick, what I did was I created this scope variable or type, I guess, and it's just a bunch of nodes basically. If we are talking about an AST, then it's just a bunch of nodes when we are talking about a scope. So it's basically a bunch of nodes. And what does that look like? So when we are running through the tokens that we have created on the Lexer, we are basically creating a global scope right now, and we are keeping track of a list of scopes. So as you can see in here, we have a list of scopes, we have a depth for the scopes that are currently existing, and we are passing that to all the function calls that we are parsing the tokens to generate the AST. So if we go in here, parse all statements, you can see that we do have this option for parsing scopes as statements. So if we go back in here, you can see that we do have a scope as part of a statement in here. Technically this right here is a whole statement, but scopes are not really limited to just statements. As I showed you before, function definitions, they are they have scopes, but they are not really a statement. They are part of the definition of the function. So they are two separate types of things. They can be part of an expression or they can be a statement. So in here we are looking for that as a statement, but if we go looking to actual function call, so here is a primary expression. If you look into it right now, this is basically assignment. We are assigning this function to a variable called something, and if we go into, if I'm not mistaken, in here in the proc definition, you see that we are not only passing the scopes that it currently has access to, but also the depth of that scope. So if we go in here, you can see that we are parsing that scope. So here's what we are eventually going to do today, but let's go back to scopes right now. You see that we are basically, after we parse the inputs and then also the output in here, we get to the actual scope. As you can see in here, this is the scope. So we parse everything here, and it's pretty straightforward. We are basically creating this new scope, and we are assigning a new scope to the global list of scopes, which is this one right here, which we have been passing to all the function calls about the statements and the expressions and so on and so forth. So we create a new scope, then for that new scope we are basically parsing all the statements inside of that scope, and then we just return whatever we got, and that is fine. And yeah, that's pretty much it. And if you go back to the function call, we are then just assigning back whatever we get in the current execution to the proc definition in here. So if you take a look at the proc definition, we have a scope. This is basically the body of the function call. So everything between this open bracket and this closing bracket is considered the scope of the function. So I just wanted to mention that because on my previous stream I was tired and I didn't know what to do, so my implementation was kind of trash. So, and it even works with if statements. So if we take a look at here the if branches, it is working the same way. We are basically taking a look at the token and then the expression, and then we find a scope and we are parsing that scope. And if we find an else if, we are parsing the expression for that. Otherwise we have an unconditional jump in here, and then we are parsing the statement again. So pretty good. But the problem that I'm trying to solve right now is that I want this to be something that actually works in some way, in that it is parsed correctly in the proc definition. As you can see, we can do the call with variables right now. It should work, but the thing is, it doesn't really do anything because it is not keeping track of variables that we are using as arguments for whatever, you know. So yeah, let's get started. Basically in here we have if you take a look, it shouldn't work, right? It will say that there's no definition for this value, or for this symbol. It's either out of scope or not defined, which is not the actual behavior that we want with this, because we technically do have that. So if you go back in here, we have all the inputs and all the outputs. So the proc definition parsing should consider that when we are doing that. So let's go back to proc definition in here, and the first thing here, basically this should do is a little bit different. So this should do is basically talking about this right here. This is not technically any sort of variable that we are creating. This is just how could I say it? This is what is the signature of the function. so there's no variable associated. It's just what we are expecting for a user to input into this function. So we can't really use the function that I currently have, which is parse a base node. So if you take a look at it, it doesn't really work well, because in here we are expecting this base node to be a variable that is allocated, when in fact it is not allocated. Which is, I mean, this is fine, I guess, but that's not really what we should be doing. And in fact, probably we need to have some sort of generalization, or we have a generic function that is parsing first the definition. So this would be the definition of a node, and after that we have, if we have something after that, so if we would have like maybe variable 1 or something, and then we have a string, this is a variable definition, and we could parse this. I mean, we could parse this part right here, this right here, and then if we have anything after that, so maybe we have a assignment to something, then we have we can use the parse base node, or if it is a semicolon, basically we are done with parsing. But not right now, I don't really want to go into that. That is too much work for me right now, so fuck that. So yeah, proc definition. So in here we are parsing out the inputs, and then we are assigning this to the inputs of the function definition, and then we are looking into the return types. And now the thing that I think we should be doing in here is that we should I don't know if that is a good idea, but what I was thinking is, with this access scope, we can basically assign whatever is inside of that input as one of the available scopes for this parse scope to evaluate and use in the actual calls. So maybe that is something that can maybe work, I guess. We can try it. So if we are parsing the scope, we are basically increasing the depth. So we first need to do the following. We need to increase that right now, and then we need to get the access scope at this depth, and we are basically appending whatever we get inside of the proc input as part of this right here. That is my guess, which means that eventually, so how it works, so let me show you guys how it works. Inside of here we have all the previous scopes available, and we are basically creating a new one, because when we have a scope, we are creating a new one, obviously. So we parse the open bracket, and then we finish with the closing bracket, but everything inside is a statement, right? And the thing is, we check for the size of the scope, because the scope is a list of lists, and if the list length is not equal to the depth in here, it basically means there's an error. Sorry, not an error. This means that we should create a new scope, and then we are creating that, and now we are assigning that whatever we are parsing in here to that scope. So because we are aware of that, it should work. That's my gut feeling. Yeah, I think it should be fine. And one other thing that is important is that we are, so this is the other thing. we check that there is a actual thing, the identifier is in scope. So if you take a look, it's similar in a sense to how we have the scope definition for the scopes for proc definition. In this right here, this function is responsible for checking that whatever we have in here as identifier actually exists in the scopes, and then we can use that in the current scope. So that would be what I showed before. So it checks in here at the global level if we have like f is equal to value is actually not inside of the global scope. The global scope is everything that is outside, is in the root level, whatever it is. So anything that is outside of a bracket is the global scope, but this value is not defined technically because it's inside of its own scope, so it doesn't have access to that. So this is what this function is doing, basically. It checks for that. And I do know that it is not the best implementation for that, because we have the nested loop in here, which is kind of really bad actually. But because I want to eventually have a bootstrapped version of my programming language, and I don't want to implement a map or a hash map or whatever, it is easier for me to have just a nested list where I can just do a loop between the two lists. And yeah, that's easier when I'm doing my implementation using my own programming language, because it's kind of annoying to implement hash maps. So yeah, now let's go back to proc definition. So in here we should be good to go, I guess. We can test it out to see if it works, and let's see what happens. It failed. Okay, let me also enable debugging here real quick. What is the actual problem? So let me decrease it here. So the problem is it's 424. Not in here, in the AST 424. It doesn't like it. Oh yeah, so it doesn't like it because we need to actually create this right here. It needs to be appended with a new scope. That's my bad. And it works. Hey, punching, is that it? Sure, go ahead. What is the question? Yeah, just for this for double checking, let me see what we have in here. I want access scopes. What do we have in here? What is the trick question approach? I never heard of it actually. So let me just do that. Result. Because it is easier to look in that way. So if we do this and I do this and remove. And then I want to look for the actual input, I guess. What is the name of the function? I don't remember. It's something, okay. Something. So this is the declaration, this is the proc. We do have the symbol, it is assigned to input 1, okay. And we have B, and it's assigned to input 2. Great. So it should be working, I guess. Okay. And then, yeah, that's something else. Interesting. It was actually easier than I thought. I thought it would take a lot longer to implement that actually. Study and run the letter permutation Java file with length 1, 2, and 3. That is actually interesting. I I have no idea actually. To be very, very honest. So I assume this is left, 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 right. That's it. So let me see what is this about, because I never heard of it actually. It is. Yeah. Yeah, I see. And is that something that you need to do for college or something? I've been out of college for a while, so is that the kind of work that you need to do? Mm-hmm. Yeah, yeah. There's always something like this. I don't really like this kind of thing. It's like you get. I mean, after college, sure, because when you are outside of college, it's like trying to solve real world issues, and sometimes you do need to get very specific about things, especially if you are in certain environments where you need to have high efficiency, low response time, that kind of thing. Then sure, it makes sense to have a in-depth implementation of something very specific. But most of the times, like, do you even care about it? Especially when you have a lot of deadlines and a lot of different projects that you need to take care. You don't really think about it. Especially if we are talking about web development in general, there's so much time between I/O that doing any sort of optimization is like, why even bother if I am stuck here waiting for like 1 second a response for something. Now if we are talking about like games, for instance, I think that would be nice. There are a few places that I think we do need this kind of thing. So gaming would be one. I think that OS development, so kernel development, that is important. If we have anything that is like mission critical, like banking, maybe. If we are talking about medicine or something, I think it's also important to have optimization in mind. But also, especially if you're talking about medicine, security is more important, I would assume. Yeah. I don't know if that was the question. If it Jesus, my brain. If it gets easier. Okay. Yeah, for sure. When I first started working, I thought I had to know like some weird ass algorithms like sorting red and black trees or something, or uh, inverting, I don't know, inverting trees in general or whatever. That's people don't even care about it. Most of the days you're just trying to understand what the customer wants, and most of the times they don't actually know what they want, so it's a very tough conversation. But don't get me wrong, it's important to know this kind of thing. uh, so my opinion is that we should know things, but in the real world it is not like that. It is very different. The expectations are very much different, you know. Just 1 second, please. So yeah, I don't feel like it's something that should be consuming your day, you know. Okay, now that it is in fact working, yeah, I don't know what to do because it was so easy. I thought it would take longer. uh, okay. Basically we are done with what I was planning to do. um, okay, can we even do weird shit like whatever, and this is basically a boolean, and we just do that for something. Just for the sake of testing as well. Yeah, it works great. So let me just include that git add whatever, and then let me include this new file, scopes, including arguments, function arguments, as whatever, it doesn't really matter, as part of scope. Yeah, that was quite a lot easier than I expected. The thing is, when I was first implementing scopes, it was kind of a nightmare. So if you take a look at this, it is not even the best implementation right now. But this right here works. This is a scope that only exists in this space. So if we try to do like f is equal to value, it will fail. So it fails because we don't have that defined inside of the global scope. Let me even go back to this and disable debug because I don't really care about it right now. So if you take a look at it is not defined or it's out of scope, and if we take a look at it, it is technically out of scope because it doesn't really exist at the global scope. It exists on this anonymous scope that is created in here. So this took a while for me to figure it out, and it's not even a good implementation, because if we, for whatever reason, we make a mistake and we forget to close the scope, it is going to hang. Oh yeah, let me actually, so this will hang. If you take a look at it, it doesn't work. Yeah, I eventually need to make it a little bit better because it doesn't consider if we don't have anything here. So yeah, that's a weird behavior that needs to be fixed later. Now that I basically fixed that, let me just change the title of the of the live, because that's no longer just implementing function calls with arguments. It already works. And because I have two different types of function, I have a distinction between a function call and a proc definition. They work independently. I couldn't implement the intermediate representation of that because I was not using the inputs as part of the scope of the function. But now if I want to implement the intermediate representation for function calls, I can, because there's a matching between the inputs of the definition and the actual call. So that should be okay, I guess. Yeah, sorry, my cat was on my table here. So what I'm thinking right now, I do want to include more types of operations. So right now I only have a few types of operations. As you can see in here, I only have plus, minus, multiplication, and less than. I am thinking about including all other operations. These two here, they don't really count. This is just for tracking errors, and this is like no op, which I don't know if that is the case, but maybe it is. So I think I'm going to include new types of operations because it would be nice to have them. So yeah, let me real quick just change the title of the string. Implementing operations, and that's it. Now implementing operations in my language or something, I don't know, it doesn't really matter. Great. So what do I want to do right now? I think the first thing that I want to do is have let me comment everything in here, because fuck everything in here, I don't really care about it right now. Sorry. And let's say we have a bunch of operations in here, and this is pretty much just a empty proc. And one of the things that I want to do is have like comparison. So let's say that a is equal to 1. I want to basically say a is equal to 1. If that is okay, I can just exit. Let me set this. So what the fuck? Why is it doing like this? I don't know. Anyway, so if we find it, that's one of the things that I want to do. I also want to say not equal. So if a is not equal to 2 or something, I want that to work as well. So this is another operation that I want. The other operations as well. So if we have like a is greater than 2, or maybe a is greater than or equal to 2, or less than or equal to 2, that is something that I want as well. So this is a few of the things that I think I'll be implementing right now, because they are kind of necessary and I've been lacking. Basically, I've been implementing other things and skipping this because it's kind of easy with everything that I have set up, but I'm just lazy. So yeah, let's see what happens in here. What character? Okay, this is the first thing that we need to fix. So let's go to the Lexer, And let's include a new token. This is the exclamation. And Elixir is pretty easy. It's like there's not much secret for Elixir. It's like any other Elixir you ever seen in your life. Just gather up a bunch of characters and create a token for them given the context. So if we have an exclamation, basically we need to, yeah, so this is another thing that I did because it's kind of, I was kind of annoyed, but because Go sucks and it doesn't have any sort of enums that actually, you know, is useful, we have this const and then we have to use iota. I am basically asserting that whenever there's something new in here, I need to fix everything. So if you take a look at it, if I kept as I had before, it should fail, saying that the number expected was 30, but I got 31. So yeah, just to make my life easier, because I have to change in a bunch of places, and if I forget I can just go back, and that's a lot easier than just trying to figure out what is the problem. And I have it in two places because if I forget in here when I'm doing a function call, I will be remembered, because I can probably just fix it in here and forget about this right here. So yeah, that's Go sucks because it doesn't have any sort of static assertion, so I have to have a runtime assertion. That's why. So whatever. Now we have the token for that, and we basically need to create the actual token. And for us to do that, it's pretty much a copy and paste of whatever I have in here. I do have already a setup for single character tokens. As you can see, it's pretty much easy. Just say if this is the token, just create the fucking token. Exclamation. And that's it. So yeah, and the nice thing is that by introducing this right here, I'm also making my life easier in the future, because eventually I will have errors inside of this language, which is an exclamation mark when we do a type definition. I can show you what I mean. So if we go in, let me see. This right here is basically my planning for the language. There's a bunch of files that I've been using as guidance on what I think would look like, how I think the language would look like eventually. So if I go into maybe hash table, as you can see, we can have errors. So here we have a function that is called init hash table, and this is the return type, and basically this is the error. We are saying that this function has an error as a return, and if it ever happens, if there is an error eventually, there's ways for us to handle. So as you can see, we have this unless, and there's a kind of a capture group. I don't know how to implement that, but eventually this is going to be a capture group. And one thing that you can notice is that strings are using these weird characters right here, because I feel like it. So that's it. And errors are just double quotes, so this is considered an error. And the nice thing is that by doing that, I can also not only say that this is an error, but I can also have reason for the error, which makes our lives easier. And we can separate the actual error by a comma, and everything after that error is the reason for the error if you want to. Eventually we'll even have string interpolation in here. That should work just fine. And if we want to have, like, for instance, an error that is something, and then we have the reason for the error, one of the things that you can do is like get the reason like this. And if you just want to use the actual error, what the fuck? If you want to just return the actual error, just return the error, that's it. So that's a better way, at least I think it's a better way to handle errors compared to other languages. I prefer this syntax because we can do whatever, and then if there's an error, we can handle the error. Or another way that we could do that is what I've been thinking about, is basically just fuck that. If it is an error, just return the error as it is. Whoever is calling this function should be handling that. I don't really care. Or the other thing that we can do is that we can say, okay, this is a hash table, but it's a union kind of thing. It's either a hash table or an error, and eventually we can catch that error. So we can say that if we catch that error, we can just use that error doing something with that. And I think that's a better solution, at least compared to other things. So yeah. Anyway, now that we have this, let's see what happens if I try to run it. It fails. Why it fails, I don't know. Let's enable debug again. What is the error? So this is the AST. If we go to line 315, what is this? Conditionals. Yes. Okay. So it is failing in here actually, which is good. This is where we are parsing basically the expressions. So if we take a look on whatever we have in here, it is failing in here. That would be my guess, because we don't really have this kind of operation available at the AST level. And actually, let me go back real quick to the Lexer, because I don't know if we have a comparison. Yes, we do have a comparison in here. Okay, so first things first, let me comment out this right here, and let's go slowly into this implementation. And the first thing is in the line of parse expression. It's not in here in the AST, so yes, so right here. So in here, the first thing that and this is not a great implementation either. This needs to change eventually, but right now it is what it is. So let's go back to this right here, and let's include the operation comparison or operation equals. And then we can basically just say, if we find a token, just use that token. So not less than, this is equals, I think. Yes. What? Okay. And this is operation equals. And now one other thing that we need to do is basically set the precedence. And I have no idea what would be the precedence. I think they are the same as this. So we could say something like token equals and then fall true, because in theory less than and equals, they have the same precedence, I guess. I have no idea, but I will work with that right now. Let's see what happens. And it works. Great. It is in fact working. The indentation is a little bit wonky, so let me, if I do this, what do we have in here? It is a little bit better. So if I just do this, where is the yeah, here it is. So basically we have an operation. This is 5, which 5 should be this right here. So 0, 1, 2, 3, 4, 5. Yeah, This is equals. We have on the left hand side what we have. Is that correct? 1. And if I go back to testing, yeah, that is in fact correct. Here is the actual identifier, and in here is the actual value that we are comparing to. So yeah, A and 1. Okay, great. Now just fucking close this. Okay, nice. Now let's do the same thing for the other operation, all the other operations actually. So we'll be doing this for everything. So this is not equals, and if we go back to the lexer, I know we don't have not, we have not equal. So where is equals? Equals, I will put them together, talk not equals. And the nice thing is that I can show you again what happens. I can run this, it will fail because I don't have 32 defined in here. So I can do that in here, and then I can do the same thing in here. So here should be 32 and here should be 32. And again, Go sucks, that's why I need to do it like that. Where is this? So this right here. So this is not equals. Now let's go back to this, and in here I need to basically check for 2 characters. I need to check for exclamation in that, and this is not equal. And this, yeah, so everything should be fine. Now it is failing exactly at the location that I expected it to fail, which is in the what is the name, parse expression, because we don't have an operation for that. So if we go back in here, we can basically say op not equals, and if we go back, we just need to change it in here, op not equals. And I think not equals is the same precedence. Probably this needs to be, I need to double check that later, but for now that should be fine. And yeah, it works. And I think it even works with with parentheses. So let's double check, because it's important for this to work on. Yep, it works. Nice. And if we want to include a bunch of parentheses, we can. It should work the same. It is nice. Just for the sake of result, just for the sake of peacefulness, here it is. Here's the scopes, but that's not what I want. This is, yeah, value 2. It should be left hand side A. Yeah, it is in fact working. 2A, and it should be 6. Yeah, it is in fact working. That is great. Close this. Nice. Now to the next one. Let's do greater than. A is greater than 2. And I think I already have that in the lexer. I mean, I don't actually. Less than. What the fuck? Yeah, less than. I do have greater than. But do I have the... I do actually. That is actually nice. Okay. So, which means that it should fail in the same location. Not this. Yes, it is failing in the same location. Parse expression. And in here we need to include a new operation actually, which is minus equal, where is less, yeah, so OP greater than. And it's copy and paste. So this is token, actually let me put them together. And just for the sake of keeping things, no, whatever, greater than, and this is greater than op. Okay. And greater than is the same precedence as everything else. And one thing that I'm not sure it works. What the fuck? What? What? What happened? Yeah, so one thing that I'm not sure if it works. Do we need fall true? I mean, I do know, or I mean, I am used to that because on C you need that. Yeah, I think we actually need that explicitly. Yes, we do need that explicitly. Okay. Because on C we actually need that as well if we want to go, I mean, we don't really need it. I think it's C99. We need to explicitly say fall true, but I'm not 100% sure. At least when I was working with when I was making drivers, I remembered we needed, and we were using C99. Yeah, whatever. Let me drink something. So it is in fact working, and we can actually double check that. Let's go into the results and do the same thing just for what. And in here we have, what is the value? Is that correct? Actually, testing, it should be 2. What is this? No, this is the scope, sorry. So 2 and A, yeah, it is in fact working. Great. Okay, now greater than or equal to, this is the other operation, which I know for sure I don't have anything for that. So here, greater than equal. So this is the other, and for the sake I will say equals because that's what I've been using, so let's keep it the same naming, I guess. Now where's greater than? Here it is. So else if token type is equal to this, just return this. This is for debugging, basically. In case there's an error, we can get the actual name of the thing. So yeah, and again, this is not the best implementation, but I know there are maps in Go, and you know they would make my life easier, but I want to make this I want to bootstrap this language, and I don't want to have to implement maps for that to work, so using ifs for that. Fuck me, and that's my language, I do whatever I want. So greater than or equal. Where is greater than? What the fuck? So this is it. We basically need to, can I put that in here, because this is technically a higher precedence. So this is the symbol, greater than equals, the length is 2, and there's better ways to do that, but fuck me, I want to do that way. If you don't like it, build your own fucking language. And it will fail again in the same place. Yes, it is. Great, so let's go back to the AST, parse expression. Let's include the new operation, which is less than or greater than equals. Now let's go back and then greater than or equals. Actually, let me do this. Greater than equals, and then we can do not greater than, this is equals, don't forget about it. Then we can just set the precedence for that, the same precedence. It's my assumption because I don't know, but I assume they have the same precedence. What? What is the issue here? Sorry. 65, okay. 117, sorry, not in here. It is failing the slice 117. Why? It is failing the assertion, sure. But why? This is the no type, it doesn't really... What is the problem? Sorry. It is on line 321. Huh? Why is that failing? Sorry. Did I not save? Huh? So in the 321, this is exactly where I am. This is parsing the scope. Why it is failing in here actually? Let me go back to here. Am I not doing something correctly? So greater than or equal, sure. And then, oh, greater than or equal to fall through should be the same. Huh. If I don't get the problem here. Because it is working technically. It is reaching here, right? Reached. It does reach in here. And what is the current token? Do I have it? No, I don't actually. What is the token? Sorry, what? Is not even... Okay, it's just slow, I guess. So it found this. What the fuck is this? So let me actually do the following. Let me go to the Lexer. Am I doing something wrong in here? Is it ever reached in here? It should be. Yeah, it is. Okay. So is this because there's a bug with my implementation of scopes? No, it is specifically this. Okay. So I did something that is broken. This is the token. What? Be greater than. We do have the operation, sure. Then the binding power for that, which should be the same. One other thing, can I just do something like this to make my life easier? Fuck, fall through. Yeah, that's a lot better, I guess. Does that work? It does, okay. But got assignment. So I think I know the problem in here, I guess. Token type. Huh? Assignment, it is finding assignment. What? What do you mean? Let me do the following. Let me print all the tokens. And I want the data. So, and let me actually OS.exit because I don't fucking care. And I want the greater than or equal to. Huh? That's a very weird symbol for some reason. I don't get it. I am specifying the symbol. This is the symbol. Huh? Why is that in Unicode? Because I think this is Unicode, no? Yes, it is Unicode. Why is that a Unicode symbol? What? It is a string. What? I don't get it. Why is it doing like this? It doesn't make any sense. Huh? Is it because of this, I guess? This is causing the problem. Let me see. And is that the problem? Sorry, not in here. In here. No. I think I know the problem. I think it's just the implementation of the thing that I have. Let me do the following. Let me actually, which actually doesn't make any sense actually. Wait. Yeah, it doesn't really make any sense because we have things like this. Or this. No, we don't. Why? Oh, yeah, I think I commented out actually. No, I didn't. Huh? So instead of doing that, let me straight up just token token slice. fmgs printf, or printf actually, and I want to know the symbol, the token. And let's get the actual token symbol. What is the problem here? It is a token. What? Oh. And then I have token show token dot token type. What is happening here? Yeah, this is not great. Let me so if yeah, that is super weird. Why it is like this? No, it is actually here. Okay. But where is this? Huh? It was working before. I think it was working before. Am I crazy? No. Did I? Yeah, I think I made a mistake in here. Yeah, this is the mistake. Okay, that's explained. That's why. But I don't get this one right here. Why this is not working? So yeah, it is working, but why you want an assignment? Choo. Why? I don't get it. What did I change actually? So I included the operations, but that's not what I want. So in the Lexer, greater than equals, token not equals, sure. I changed the assertion, I included the comparison, greater than equals, that should be fine because the length is true, this is true, this is 1, token assignment. It is doing that twice for some reason. So if I do greater than, what happens if I do this? No, it's still the same weird behavior. Oh, that's fucking why. That's why I'm fucking stupid. That's why. Damn. Yeah, that's why. Now it fucking works. That's a stupid mistake. Sorry about that. Oh. Yeah, let's go back to this. Let me remove this. That was weird. That's why it wasn't working. Sure. Save this. Yeah, nice. Okay. Finally. Fucking stupid mistake. So AST, we do have this right here. So now the last thing is greater, is less than or equal to, which I know for sure we don't have that in the Lexer. Less than equals, yeah, no, less than yeah, let's just copy that. This is 34 now. We have 34 tokens. Less than not here, but in here. No, oh, sorry, here equals, and then in here it's 34, not 33. Nice. And then the same thing in here. And actually I think I'll do something a little bit different. I will remove this, I will make it go up here because yeah. What the fuck? Okay, so now we have something with 3 characters, then everything with 2 characters, and then 1 character. And then we can just copy and paste and not do a fucking mistake that is stupid. And this is less than. Let me close this, and then let's go to the AST, and in here less than equals. And then parse expression. So now greater than, where's the less? Yeah, this is a mistake. This is less than. less than equals, and then less than equals is the same precedence as everything else, so we can just say that it's talk less equal and let me actually do the same thing for plus because it's annoying. I don't like fall through, it's kind of very much the annoying thing. Can I even do this? Does it allow me to do it like that? I think it does. It is not complaining. Yeah, just because there's no fucking comma at the end. No, you fucking can't because it likes to opinionate on your fucking style. That's okay. Who cares? Nice. It is in fact working, so let's look at the results. So we have the scope, but we have in here the right hand side, which is a 2, and the right hand side it's a, I assume. Yes, it is. And operation is 9, which is the newly added less than equals. Nice. Okay. Yeah, I think it is okay now. We did implement a bunch of operations and they are working. Now, one thing that I want to double check is that we can have yeah, one thing that I would like to have in here is the OR operation. So this should be a thing as well, and then we need to include something in here. So let's see if we can do something like this, and then we have like b is equal to 2 or 4, I don't know. B should be equal to 2, so this should work as well. And the OR has a higher precedence than this, or it's a lower precedence. I don't know, but yeah, whatever. For now, let's just, I don't really care about precedence right now. I just care about implementing these operations. So this is token bitwise OR, I guess, or just OR. This is not even bitwise, this is just token OR. I will do OR, and OR for boolean, and bitwise should be overloaded, but which basically they work the same. The same token works for booleans and also for bits. That should be fine, I guess. So yeah, now this is the 35, and then we have the new token in here, which is the token OR, not okay, OR. And in here it should be 35. Did I fix it? Yes, I did. Now let's go back in here and include a few more tokens. So this is the same as before. And in here, what we have it like this. And this is the symbol. And this is not less than, this is OR. Now if we go back to the AST, we need to create a new operation, which is OP OR, and then parse expression. We can just basically do this. OP OR. And then we need to have a precedence for that, which I have no idea what is the precedence for OR. So I think it is lower than this. So it should be probably lower than the comparison. So token OR should be something like, I don't know, 4, I guess, because we first need to evaluate this, and later we can do this. I think that would be the order I would expect. I think that is the order. And it is in fact working, I guess. First try. So if we do something like this, and then we go to, I think it's, what is the operation? I don't remember. It's 10. So p type, this is the scope. In here I want the operation 10. Nice. Okay, operation 10, we basically have the left hand side should be a, right hand side, so we have a nested thing, right? All right. I don't think it worked actually. Here is 1. Here is 2. Yeah, there's something wrong in here. Let me go back to testing actually, and let me comment out everything else, because I don't really want everything else. I just want the, oh yeah, it is wrong because I forgot. Okay, let's go again. So if we go back to operation 10, we don't have operation. Why? So a bunch of operations, we have A, we have B, and then we have conditions. We have one condition, and that one condition is basically, this is incorrect, but whatever. Right hand side. Yeah, now it is actually working. We have on this left hand side, we have 1, and we have operation 11. It is 11. Yes, it is 11. And then we have on the right hand side B. No, that is actually incorrect. Sorry. No. So this is higher precedence, right? So let's use this as an example. If we have A plus B times 2 times C, whatever, basically we want this to happen first, which means the precedence of multiplication is higher than plus. Sure. And then Okay, so the multiplication is higher. So if we have something like a is equal to b or a is equal to c, basically we want this to be higher precedence, which in fact it is, than the or, because or is evaluated later. Right? That's incorrect then. What do we have in here? So if I go into the testing here, on the left hand side we have this right here, which is a, which matches this. Okay. Then on the right hand side we have 1, which is this right here. Sure. Then on the we have 1, sure. And then the right hand side we have something, and this something is basically what is that? B. It's a binary operation, sure. I think it is correct, because on the right hand side we have 2, on the left hand side we have b. We are doing some binary operation. This is considered the right hand side for this entire operation in here. No, it should be the other way around actually. That's not correct. Because on this right hand side we have 1 doing this operation between these two. So yeah, I think the weird thing is, right, if we had something like, let me create something that is similar to this. If we had something like a times 2 plus b times 3, what I would expect is this happens before, so these two happen before the sum. That is my expectation, which I don't know if it is the case, so let's try it out real quick. And I think it is in fact correct. We have a, so one thing that I can do to make it easier for me to understand is having a debug tool, but I'm too lazy to do that right now, so fuck that. I don't want to do that. Let's keep it simple for now. This should be the correct approach. And in fact it is a little bit different, because we have in here a operation which is the first operation, which is this left hand side and right hand side, and then we have the other operation on the right hand side with a bunch of things internally. So yeah, I think there's a bug in here somewhere, but I don't want to check that right now. Yeah, I don't fucking want to do that right now. Fuck that. Whatever. But I can even do the following. There's a maybe should do. I think there is a bug in here somewhere, or maybe in the parse expression function, because the AST for the expressions are not looking correct. Yeah, let's look into that later, because right now I don't want to look into that. I plan to eventually have a intermediate representation, and with the intermediate representation it will be a lot easier to see things as they are, because with this AST it is just too much, I think. So with the intermediate representation it is a lot easier to actually be able to see what is the result of the AST. So when the time comes we can fix that, and it will be a lot easier. So yeah, it is working nice, even though it's not correct. If we don't have the precedence is messed up, that's fine, because we do have the parentheses to specify what we want to do and the order that we want to do, so that's okay. Now the other thing that I want to include also is the AND operation. So A needs to be equal to 2 and B needs to be equal to 3, and it should be similar to everything that we've been doing so far. So let's go back to the lecture, because I don't have that token there, and that would be token AND. .36. I can even do something like this, I guess. It is a lot easier. So copy and paste, instead of or it's AND, and then we can increment it. And in here basically we just need to create a token for the AND operation. Which is straightforward, I guess. In here, do this, and this is the AND operator, not operator token. And now let's go to the AST, because I need to include a new operation. OP AND, parse expression. Here it is. And the binding power, it should be the same, I guess. Again, I don't know the precedence for this right now. I don't want to worry about it. I just want to make it work. And it seems to be fine. So if we look at operation, and I think that would be 12, yes. So this is the operation 12. On the left hand side we have another binary operation with 6, and then on the one side we have, this is wrong, whatever, I need to fix this, I guess. I will fix it later. Let me finish this. So we have 2 in the left hand side, we have a, yeah, I guess that is fine. It shouldn't be typed, there should be a symbol in the name, but that's okay. We have a value of 2. It is an integer. Sure, on the right hand side we have another one. We have this as b. Again, shouldn't be typed, should be a name with a symbol, but that's okay. And then we have 3. Yeah, it is looking alright, I guess. So let's see what do we have in here. Let me revert whatever I had in the hash table for the explanation. Is not revert, it's restore. Yeah, so let's add everything here with the exception of result, because I don't really care about result right now. So git status, git push, not put the commit actually. So this is basically including a bunch of operations. Including binary and comparison operations. Yep. Yes. And then we can just push. So if we look into GitHub right now, I think everything in here is looking good, I guess. So here it is. It is not refreshed. Let me do that. What are the changes? I think I did a lot. Yeah, so a lot of operations in here. A lot of operations. Here are the tokens. Moved things around. Included this. Yeah, it seems to be working fine. Okay, good. So I think what I will do right now, I will do just a quick break because I need to use the bathroom. So be right back. So be right back, guys. Hey guys. So now that we are basically done with implementing operations, I think I will start working on going back actually to start going back to type checking, I guess. Hey Rock, how are you doing? So yeah, I think I will work right now with type checking instead of doing new tokens. I think I'm tired of that. So let me change the title here. So type checking. I'm good actually. I just finished my tea. I've been doing this language here. It's called Chaos because I think it's funny. But yeah, I'm good. I'm having some Coke right now, so some zero Coke, and just programming for fun. So type checking. Yeah. So let's go back to I can show you how it works actually. So it is a typed language, so I can show you what it looks like. So this is a typed language that is compiled. For now I'm working on the AST and type checking, and eventually I will have the intermediate representation and also compiling this. I think that I will be working with FASM for now, and eventually I can use other assemblers, I guess, but I will just start with FASM because it's easier. I mean, not easier, but it's the one that I kind of know. So there are the default things. So you can define a function using an assignment. So we have this assignment here. This is basically a compile time known thing. So this is a function. We have conditions. We have this intrinsic that is exit for the exit call. We do have scopes. So as you can see, there's typing inference right now. As you can see, this right here is considered to be a signed 64 by the language, but if you want, you can say that it's unsigned. That will work as well. We have strings by default. I don't want to have weird like C# type of thing, although I will eventually have that available for people. If they want to have that kind of thing, they can, but this is how you specify a string. Here's how you specify a return. There's a function call. There's the default behavior as you would expect for any kind of programming language, right? And yeah, we have branching. We have the operations. I was actually implementing a few other operations. As you can see here, I just implemented the comparison and then the OR and AND in here. So yeah, and now I'll be working on the type checker now, because I do have the type checker in here, but because I changed how I am handling scopes, it's no longer working, because in the past I basically had a global list, or it wasn't even a list, I think it was a map of allocated variables and functions, but that is not great. And I implemented something a little bit better for keeping track of different scopes when we are running a program. And right now, if you take a look at the not this, where is it? Yeah, let me include this. So import fmt. So if we go back to here, this is the error that we'll be getting now. This no longer exists. This used to be actually a map of nodes, but because I no longer have that, I keep track of different scopes across the program. This is basically trash and doesn't work, and I need to fix it. And it was pretty bad implementation, I guess, because it's basically just a loop, and I don't like this. So yeah, let's look how to make it better and not do this weird ass fucking shit. So the first thing that I think I'll do is just delete everything. No, not everything, but most of the things in here. Especially this right here, because I don't really care about it, I guess. And I think I'll just care about identifiers for now. And basically what I think I want to do is something similar to what I have in the AST. That is, I have a main function call that then passes a slice, and I do a bunch of different operations later. And I can just match the type, basically, because I have a tagged union for different nodes. So each node has a specific field with a bunch of different things, and I think I'll be using that to identify how I'm passing that around, and how I'll be handling that. So I think the first thing that I'll do is just have like type check identifier or something. I guess that is the best approach. Oh man, I initially I was thinking about using not even C++. I was thinking about C. But when I first started it, I didn't really know what I wanted for the language, and I wanted to make faster iterations so that I could test things out. You know what I mean? And this language changed quite a lot. I first started it, I think 2 years ago or 3 years ago, more or less. But only now it is looking promising. Before that it was trash. I think let me show you how it used to look like. I have everything here, fucking here. So if we go back to my first implementation, or I mean not even implementation, my first design of the language, it was so fucking bad. Let's go back. GitHub, am I right? So fast. Can I just go? I don't remember. I don't know how many pages we have in here, so let's go page by page, because I think it's the number of commits, I guess, and it's 166. Yeah. So here is my first commit, and the language looked like trash. So it did change quite a lot. So this was how I used to, define functions. I was trying to have explicit returns when we have pointers, and because when you have pointers you can basically just return for but having an explicit way to do that, but that's kind of annoying. So I just basically removed. Initially I was thinking about having different types of returns, so if you had an error you basically raise the error, but that's actually a trash idea as well, so I just straight up deleted that. And there's a bunch of things in here that simply they don't really work. So these this thing that I was stealing from Python, where you have like a formatter for the structs, that's trash. I don't like it. I eventually just threw it away. I had this idea of using let to specify variables, but then I started to look into like JavaScript and Rust, and I just hated the way things looked. So yeah, I started to just implementing not even the code itself, but ideas for the language. I started to design this language, and it started in 2024, but I had the idea before that, and I didn't really have any repo or anything. So that was, I've been working on this for a while, and only on my free time. But because I wanted to have a faster iteration, I chose Go. And I kind of regret that, because Go is super annoying and I hate it. But, you know, that's how life is, I guess. You know how things work, and you may hate them, but you know how to work with that. So, but initially I was thinking about C, because I prefer to have a low level access to everything. So I don't mind having to allocate memory and keeping track of everything and debugging when necessary. But I didn't really want to take time thinking about that. So I went with Go because it is compiled, and also it's garbage collected, so don't need to worry about it. Yeah. And what is your idea for your compiler? What do you have in mind? So we are type checking identifiers in here, so we get basically the program, and it's a pointer to chaos slice, and this is a bunch of nodes. And I think I need to also provide a scope, I guess. I mean, do we need? Yeah, I think we do. So if we find no, fuck that. No, I will be doing that for each of them. So yeah, let's do that. We basically consume assert this. Yeah, that's pretty much what I am doing right now. I do like C. I do like the simplicity of C, but I also would like to have other things in the language. So I am doing this just because I, is what I would have liked if I was working with that language. Yeah, I see what you mean. Yeah. Linking is something that I will be working eventually, I guess. For now, I literally just want to have a bare bones compilation. So transform the file into a bunch of tokens, and then this bunch of tokens into an AST, do a type checking, transform that into the intermediate representation, and then compile using Phasm. Compile into assembly using Phasm. And eventually we can think about optimizations, but this is the initial idea. I do have an entire thing just for the design of the language. There's a bunch of things that I planned over the years, or over the months that I've been working on this. The one thing that I really want to eventually have is what I'm calling scaffolding, which is basically a interface in TypeScript, I guess, I don't know if there are other languages that use this, maybe Rust with the traits, but it's not really traits. And basically it's a definition of a struct, but you can also have methods that you can create. And when you define a new struct, basically they require to have these fields, and they require a method for them to work properly, otherwise they will fail. So as you can see, I have in here a scaffolding, and this scaffold implements this struct example. And as you can see, the idea is that it will have these mandatory fields, but if you want to include all other fields for whatever reason, you can. But the thing is, this struct needs to have this operation as well, because it's defined at the scaffold level, which makes life a lot easier. And this is a mixture of duck typing with strict typing. I don't know. It's like duck typing, but better, in my opinion. And the one thing that I want to also include is this, which is basically a label to a argument that you can pass through structs, because my idea here is that you may need to implement something, but you don't like the name. So basically you just say, okay, whenever we have a implementation of that scaffolding, you have this as the name that the scaffold is expecting, but when you are instantiating this new struct, you can have whatever you want, so field. So when you are instantiating example that this example, we could say something like field 1 is equal to whatever, instead of having this gigantic name that is super annoying to write, you know. But yeah, this is something that I really would like to have in other languages that I work with, but I don't really see them very often. I don't see them at all, actually. The closest thing I think would be Go with interfaces, but they only have interfaces for methods. You can force fields, but it's kind of annoying, actually. So, and there's a bunch of things in here for that. So yeah. Now, going back to type checking, we get the identifier in here. Yeah, so this is important, I guess, but I think I will skip it for now. So let's start simple with this example right here. Let me just comment everything and start very simple. So if we have a equal to 1, that's the first thing that we need to do. And I think I already have pretty much all the implementation for that, which is nice, which is this right here, but I will probably be changing a few things. So yeah, I not only need the scope, but I need the depth. And in here we have this. So what we have in here, let me also comment everything out, because I can just double check later, and I can just call this, and we are type checking things, but we are only type checking if we match the identifier. Otherwise we continue because we don't really care. And we are consuming it in here. Sure. And also in here we not only accept the program, we need to pass the global scope, which we have defined prior, and we need the depth, which is an integer. So if we go to the AST, we need to return a bunch of things actually. So let's do the following. So it returns this, a list of scopes, and also an integer. And this is going to change drastically. So this is the program. So we return the program, we return the access scopes, and one thing that I can do, I can even make sure that this is not uppercase, because this is not public, and this also is not public. It used to be public because it was a global thing in Go, but it's no longer public. So access and depth, and if we go back to here, we can now basically have in here. So this is the AST, we have the program, we have the scope, and we have the depth, and then we can pass that to the type checker in that order. Great. Okay, so let's go back to AST. No, not AST, to type checking. And then we basically need to pass everything that we had before, which is not this, but the program, the scope, and then the depth. And this is probably eventually will become a struct, I guess, because we are repeating this a lot all over the code. So eventually I will simplify this, I guess. What inspired me to make my own compiler? Oh man, that's a good question. It was basically my frustration with other languages. So I used to work with Python. So I first started to work with C actually. My first development job was basically C. And I used to make drivers for the kernel, but it was for a company. So we were basically doing security for kernel, and it was actually super nice. I really enjoyed that work. I really enjoyed working with C, and working with C at the kernel level is very much different from user space. And there were a bunch of weird, quirky behavior and weird macros, and a lot of weird things. And I really enjoyed working with C at the time, but I started to see patterns that I really didn't like, because there was a lot of repetition and a lot of implied things on C, if you know what I mean. So for instance, C doesn't really have an error type. There's a lot of error null, or you can return null, or you can create your weird ass error type thing, but it's implied most of the time a few things like errors, or how to handle things, or how to initialize variables. It's very much not explicit in a sense. So I started to question, maybe I can do something at least for fun, And after this job, I changed positions in the same company to work on a cloud platform basically, and we basically did everything using Python, which is a nightmare on its own. I don't know if you ever worked with Python in a large scale with like a critical service with roughly 200,000 lines of code, but there's a lot of magic happening because Python is interpreted and it's dynamic, and it's super annoying to work with Python at this level because just because it's a lot of magic, and that was very frustrating to me. So I was like, maybe I can just do my own thing. And during the lockdown for COVID, that's when I started to think about it, especially because I was doing my master's degree and I was talking to a few of my colleagues, and they were like, oh, maybe that's a good idea. And I started to share with them some of the ideas that I had about creating my own programming language. And that's when I basically started to create this. It was out of frustration and isolation and also to try something new because I never created my own compiled programming language, if you know what I mean. It is easy to create your interpreter, so something like JavaScript or whatever. It is easy to do something like this, but I never created like a full-on type checked creating AST from tokens and then compiled language. So that's where it came from. Basically, curiosity, creating something new, and frustration. Sorry about that. I don't know if it is the same experience you have. Maybe you have something similar, I don't know. So let's see. If it is a int literal, we get the variable type, the value, we are casting this. If it is okay, these are the values that we are allowing for the type. So in theory this should be working, I guess, and we shouldn't see an error. As I say, it happens. Okay, but this error is actually because of this right here, and I need to actually continue, and it is in fact working. And let me also just remove this printing because it's kind of annoying. I don't really care about it. Yeah, that's it. So let's go back. So this is working. We are checking the value of the node. We are checking the type. If the types match what we are expecting because it's an int literal, then that's okay. If it is not, we are asserting it failed, and we can even double check if we pass something that is not. Actually, this doesn't really work as expected because we are basically inferring the type, I guess. So if we do something like this, it shouldn't work. So I think this is going to fail. Sorry, I meant this. It is going to fail. Yeah. So value 1 expected type for signed or unsigned integer, but got a string. Great. So, and I can, yeah, I will not disable debug for now. And then we can just remove this and it is going to work. Great. Now, if we find an identifier, it can also be a string. So let me get the one for strings. And I had that already implemented. So if we find it, and the thing is also, if it is not okay, otherwise we need to return. That's it. I think that's it. Sure. And here is the same thing. I just return, I guess. Yeah, Oh yeah, no, I get it. Yeah, no, that's a valid reason. I also did something in the past and I failed miserably, but I failed miserably because I didn't really know what I was doing at the time. I was, I, I mean, too young is not always the reason, but I didn't know any better, if you know what I mean. So I didn't even know how to start, and I basically was not able to do anything. But the problem was I didn't know the concepts that I needed to know at the time so that I could do what I'm doing right now. So I didn't know what was a Lexer. I didn't know what was the AST. I didn't know about intermediate representation or type checking. I don't know still a bunch of things, but I kind of know how to implement something that should act like the things that I expect. So at least that. But for instance, this that I'm doing right now, this type checking, I don't know if this is a good idea or not, but I'm doing it to see if it works, and if it's working, then that's fine. Otherwise, I can just try it later, do something different. But I do understand what you mean. It happened to me as well. It happens more than you think. So yeah, this is a string. So if we have b, this is the string something, and this should be working. Yeah, I forgot the semicolon. It is working in fact. So if I say this is unsigned integer, it is going to fail. Okay, so at least that is working. This is the most basic operation of all. And I think that we need to return a boolean, I guess, eventually, because I'll be calling this function inside of it again, and we need to differentiate, and I don't want this to be a problem. Yeah, whatever, for now that should be fine. So the other thing that I want to do right now is basically infer a type given another identifier. So C should infer that it's a string from this. So let's see, I think I had something like this before as well, where I implemented a basic version of that, but I think I just fucking deleted it, I guess. I think I deleted it. So no, I think that's it. That's it here. Yeah, I get it. Yeah, that the whole conversation about what is an expression and what is a statement is kind of difficult. I also had some problems with that because it changes, right? I don't know a good definition for either of them. So if we look at maybe, so let's look at it this way. So if I go back to this right here, so I think I have a few examples in here. So this right here is basically a function, right? Don't mind everything else here, just stick with what I have. This is a inline function. This is basically acting like a macro, but for our purposes here, this is a function that is a method actually. So this technically is an entire expression in my language. Sorry, not expression. This is a statement, which means that we can have expressions inside of it, which we do, because as you can see, we have a scoping here, and these things here, they are more statements. So where is the line between expression and statement in here? It's kind of difficult, and initially I had a lot of difficulty trying to understand what is what, but again, we can have an even simpler example, I guess. So yeah, this is incorrect. So this right here is a simple function. This function is technically a statement, but if you look closely, it's not really, because this is an identifier, and we are assigning something to that identifier, but as a whole it is a statement. But this right here can be also a statement as well. You know, it's kind of crazy. And this is a statement, but if we have like some function and then we have whatever in here, this is a statement, but this right here, some function, is no longer a statement. It's an expression, and the statement is everything. So yeah, it can be blurry, I guess is the word that I'm looking for. And for this language, it doesn't even work to say that any statement is something that ends with a semicolon, because this function definition doesn't end with a semicolon, and it's a statement. So you know, computer science, only crazy people like it, I guess. Anyway, let's go back. So I want to infer the type. Let me copy paste this, because it's exactly what I want, and it makes our lives a lot easier because I had that implemented before. So if we find another identifier, which we can find in the assignment, this is the symbol. For now, this right here doesn't really matter, I guess. Eventually it will matter. Then we get the left hand side type, and if they are not this, then we assign and then we just return. I guess that should work. It doesn't fail, but does that actually work? So let me actually print the program data. So C has a type B. Yeah, no, that's fucked up. And it's a bug, actually. I've said that I needed to fix that, actually. So let me go back to AST, because that is something that is annoying, and I've been postponing it. So in the primary expression, this is an assignment. I don't really care about it. This is returning, it's an early return, so I don't really care about it. Right? No, I do care. This is where I need to do the change. So first thing, we do the variable declaration. Sure. We get the type. This is the type. Wait a second. Yeah, so we do get this and this. Sure. If it is a semicolon, we don't care about it. Just move on. if it is a semicolon, so it's assignment or a column, we do that. Yeah. So the thing is, right, CMake is a mess. CMake is a mess, especially for large projects. And when you start to include a lot of dependencies and weird, conditions and whatever, it is annoying. Because CMake is not even a real language, if you know what I mean. That's why I do enjoy J, for instance. The way that they handle things. I think that even Zig has something that is nice, which is if you want to compile the language, if you want to compile anything in the language, use the language itself, because CMake is a dependency on itself for anything. So if we have like a C++ with CMake is already a big dependency for building your project, so I don't really like it. And it's not really that difficult, I guess, to build your own simple build system. It's basically just calling whatever compiler you have as if it was a programming language. So I don't know if you ever heard about sorting. Let me show you. There's knob.h. I think that's so this is the build system. It is quite nice because it's basically a build system for C, and it's built on C. So if you need something, you write that in C, compile that program, and will build your project that is written in C, which is, how you would expect something to work, because you use the language itself, the language that you will be using for building your project. And it's quite nice. There's a lot of things in here, and there's no bloat in here. It's literally built for you to use as another tool on your language, And J does that by default, if I'm not mistaken, in their core or main libraries or default libraries. And I think Zig has something like that as well, maybe Rust, but I don't know. So this is a good example, I guess, of a build system that I think it's good. If you want to take a look, let me give you the link for that, actually, if you don't know about it, which I think it's kind of hard to not know about sorting, but here it is, if you want to take a look. But yeah, CMake by itself, it's like a huge fucking mess. I have seen things in the past which it's like crazy. Also package config, it's too much. I try to avoid this kind of things because they are so bloated, and I feel like I feel the same as you do. I don't like it. I rather have a full language where I can do whatever I want than have the weird definitions and weird ifs that CMake has, with weird fucking functions that they are not really functions. I hate it. And also another thing, for multi-step builds, CMake is so fucking annoying, especially if you want to what is the word I'm looking for? If you want to hard code commits, for instance, in your binaries, it is super annoying to do that kind of thing. You can't just like get a value get the number of the commit and then cook that inside of the binary using a header file or something, or a define or whatever. It's super annoying to do this kind of thing, especially if you have incremental builds. It doesn't work all the times. So yeah, it is annoying. So what I'm trying to do here, yes, we have an identifier. If we have the identifier, but we don't have actually. We skip this because we don't have semicolon. We don't have that. We have column. If we get column, yeah, so this is the expression, this is the assignment. So it shouldn't be type, I guess. That's the confusing thing. That's the thing that I'm confused, because if we go here, not here, but here, the node type is this. This is the var declaration. So in here, we get the identifier. And this shouldn't be type, this should be name, I guess. And is that fixed? It is in fact fixed. And in here, we also have to have that fixed. String something, sure. Symbol B, okay, that is fixed. That is the problem, sure. Okay, so let's go back to the type checking. And now what do we need to, no, actually, before that, so we do have it in here. The token type should be infer, I guess. So let's go back to, no, where am I? So this is the name. And then we are returning basically. Yeah, so we are returning in fact. Not here, but also here. So we don't find anything, we basically break. And then we return. And then when we are parsing the identifier, not conditions, not exit, this is the identifier, but this is primary expression for assignments. I don't care about assignments. This is the variable definition. Yeah, we are setting that as token infer. Variable declaration. Yeah, it should be inferred, right? We are not changing anything after that, I assume. Are we? Do we have anything? Only if we have a type. If we don't have a type, we are basically skipping. And then we are here to infer, and we should infer if the node is a string, if it is a literal. So now we need to do something, right? Or no? Did I do something weird? Because C should be saying that it's a string, but it's not. But B is a string, so let's go back to type checking. So type checking, let's see what is this. and left hand side, and then right hand side. So left hand side, what is it? It's B. It is a string, in fact, and C, it is not being inferred for whatever reason. Why it is not set as token infer, token type 3? It's because I think I fucked up. Infer type, infer node, infer token. What is the name for the thing? Infer type. This is a type. And I don't set the symbol. That's why. Node var deco. Actually no, because in here we do have a symbol. What is the problem in here then? Because this is the type symbol and it's not inferring, and is that the identifier? Where's the... It is in here. So what do we get in here actually? So not slice debug, we can take a look at the expression, and here is the problem. So here, I don't know the line, so but where is the... Here's the problem. B token type whatever, so it is not inferred in fact, and after that here's the problem. It is incorrect. Why? No, not, sorry, not this, the node, I guess, because the token will be whatever. So we have C, token type 31, and if I'm not mistaken, token to string, if we pass token infer, not that, token infer that, what is its token for? It should be 31. It is 31. So it is correct. It is in theory correct. So why are you not type checking then? I know why it is not type checking. Do I? Because if I see this node, then it will be. I think that's the problem. It's because I'm not fucking updating. No, it isn't. But I mean, why token identifier, this and that. Don't get it. Huh? Yeah, I think I am tired and I'm not I'm not able to find the problem because I've been doing this for almost 3 hours. Yeah, I think I will stop for now because I'm tired and I've been streaming for almost 3 hours. And I don't want to do it right now. I'm just tired. And I will start to do small mistakes. Especially because I already worked the entire day. So, and it's almost 3 a.m. for me. So yeah, I think that will be it for today. But it was pretty good today. Before I go, let me just real quick show what we did. So if we go in here, just to not this, sorry, not here. If we go to here, then to here, let me disable type check for now, and it will complain about it. So let me just yeah, so here I can show you what we did so far. So everything here, it is working. So a bunch of things went very well. So we do have now a bunch of operations for a bunch of Boolean operations. So comparison, it is working. We have OR, we have AND, we have greater than or equal, less than or equal. If we want, you can have less than only, and that will work as well. Yeah, sorry. So exit 0, that is working also, which is great. It should all compile. We have different scopes. We do have inputs. The initial idea for this string, which was pretty quick actually, was to allow us to use the inputs that we specify in the function as part of the scope of the function. So it is in fact working. Scopes inside of functions are working. So yeah, that was a pretty good stream, I guess. And if we try to run it, it is working. We can even check that it ran successfully and returns a 0. So yeah, pretty good string, I guess. A lot of things done today. And thank you very much, Rock. We see you around. Have a good day for you. I don't know if it is day for you or night, so have a good day.